Welcome back. This is question 3. Similar problem to previous one, except we have sine. So we're just going to start it the same way. We'll write down sine of x, Maclaurin series, which we know from question 1. Alternating with odd exponent values and odd factorial in the denominator. And now we just multiply or replace x with 8x. Okay. It's not going to make any much changes except for this one right here. With 8x, exponent's still the same, and denominator still should be the same. Now we have to multiply by 6x squared, and that's going to give us, could do 6x squared outside first, just to see what we're working with. And just expand this out a little bit. So we can separate our x's and coefficients. Okay. Now we can rewrite that back inside. That gives us 6 times -1 to the power of n, 8, 2n plus 1, x, 2n plus 3. And our denominator still hasn't changed. All right, to identify the specific coefficients. The actual index of summation could be modified for a specific n. So we can have this 2k plus 3 as an example, which is equal to n. This can give us k equal to n minus 3 over 2. We can plug that in into our equation specifically for our n's, so c of n. We can have 6 times our -1 alternating, but this time it's n minus 3 over 2 times 8 n minus 2 over factorial n minus 3 over 2. Or, sorry, over n minus 3 over 2 factorial. And if n is greater than 3 and n is odd, we can use that equation. And if n is even, because this is sine, remember, it is 0. So plugging this in, I'm not going to go through the hassle of doing all of them. It's just plug and chug at this point. But we're asked for 3 through 7, I believe. Yep. So we can get our odds out of the way. We know it's 0 at least. And our evens is going to be 48, -512, and 1,638.4. That is our solution to question 3.